Welcome to June 25th LeetCode Challenge, Non-Decreasing Array. Given an array nums with n integer, your task is to check if it become a non-decreasing by modifying at most one element. We define an array of non-decreasing if nums index I is less than or equal to nums index I plus 1 holds for every I 0 based, such that we have 0 being less than or equal to I, which is less than or equal to n minus 2. So given this array nums here, we find it to be true because we can make it a non-decreasing array by modifying at least one element, and the element we want to modify is the first element, right? If we modify that to a number less than, say, 2, such as 1, then we get a non-decreasing array. Or you have to modify this array nums here. So it has 4, 2, 1. That's just false because we can't get a non-decreasing array by modifying at most one element. So we have n equals the length of nums. N is between 1 to 10 to the 4, and nums index I is between negative 10 to the 5 to 10 to the 5. So in order to kind of solve this, we'll kind of use, I guess, probably a greedy approach like algorithm. So the approach we'll take is a greedy approach, and for the problem statement, it's clear that we have a number of, so we need to find whether it holds true for every I. So let's find ways that it violates this type of, that where it does not hold true, so we check for it. Say this violates, so if we have something such as nums at I minus 1 is greater than nums at index I, this is not true, right? This will make it non-decreasing because each number before it is greater than the number after it. So this will violate it. Say we have for example, the array of nums at 1, 2, 4, and 3, right? And this will make it false. That's one case. So it violates it at this index here because if we can make it non-decreasing by modifying the violation, then we could actually make this true, right? So in order to modify it, we say we modify it to something that's just 1, 2, 3, and 3. So we just made a change at index 3 here, or 2 I should say. Then it makes it true. So therefore, we can see that we actually made the modification of nums at index I minus 1 to be the same as num at index I. Right? And that's what we just did to fix the violation. So after fixing the violation, it becomes a non-decreasing array. Alright, so let's take one example. We'll keep that in mind, right? If we have this situation here where it's a violation, and we make this change, therefore it surpasses the violation and makes it valid by making one modification. Say we have example number 2. Say we have an invalid case such as the array of 3, 4, 2, and 3, right? Here you see that there's a violation at index 2, or which is this array right here. So if we say if we make it a change, one modification, do we make it say 3? Say we make the change to 3, 2, 3. So if we do make that modification, this is still a violation because the array is not in decreasing. It's not in decreasing pattern, right? So in this case, the invalid case, we can observe that if we take into account let's say nums at index I minus 2 as well, then we cannot, even if we make one modification, it will not make this true. It will not uphold for every I. So let's kind of erase this case and think of another edge case. Say if we have the following 3, 4, and 2, we know that there's a violation existing at index 2, which is for the forest, and we make the following modification. Say we make the modification of 3, 4, 4. here we basically do the same thing we done here up here. We made basically nums index I minus 1 equal to nums index I. And actually this time we do the opposite. We do nums index I is equal to nums index I minus 1, and we make it the same. Therefore, we kind of fix our violation, right? And this makes it non-decreasing. So we want to check for kind of 3 edge cases. And so, kind of summarizing what I said so far, we need to count the number of violations in the input array. So we have basically the number array. We need to find basically how many times it violates the non-decreasing pattern, and then we could fix at most one of them. So if the count is greater than 1, then we return false, right? For any violation, if we have to check to see if nums at index I minus 2 position, right? If nums I minus 2 is greater than or equal to nums at index I, then we perform the equivalency, right? We make it the same to fix the violation. So let's just call it the number of violations, right? And we're going to count that to be 0. So we're going to cycle through for each index I in the range of length of nums, between 1 to length of nums, I should say. Iterate through each number. If nums at index I is less than nums at index I minus 1, then we would have to basically increase the violation count, and we actually make that equal to 1, and we return false. Else, what we do is, so this is if the violation is greater than, if it's already 1, then we add another violation to it. Therefore, we can make at most 1 modification. So therefore, we just exit return false. So next thing we do is, if it's the first violation, then we just increment it by 1. And then if I is greater or equal to 2, and nums at index I minus 2 is greater than nums at index I, this is the thing we talked about before, then we can actually make a modification, right? So if there's 1 violation, we increase the violation, and then if these 2 conditions exist, that means there is 1 violation. That means we're able to fix it by doing the following. Nums at index I will be assigned, that'll be the same number nums at index I minus 1. We make our fix, and then if everything goes well, return true. So let's run this, and then I'll walk through the code again. Submit. Alright, accepted. So basically what we do is we can initialize a variable called violations to 0. That means that we don't have the non-decreasing array, and we'll reiterate through each number, and then we find the condition where it is a violation. It is a violation when the nums index I is less than or equal to nums index I minus 1. So what we do is increment violation by 1. If it is possible to fix it, and where the case where we have I is greater than or equal to 2, and the nums at index I minus 2 is greater than or equal to nums at index I, then we just make it the same number, therefore we're fixing the violation. However, if the violation is already 1, that means that we cannot make 2 fixes, so therefore we just return false. And we have basically our time complexity being big O of n, because we do a for loop through length of size num, which is n. And space complexity is big O of constant space, because we just return a boolean. And that's all. Have a good day, guys.